We've all seen beautiful time-lapse videos showing clouds moving quickly or crowds scurrying across an intersection. Recently I've seen more of these where the camera pans during the shot, creating a cool effect. Taking a photo like this requires a rig that can slowly turn the camera, taking minutes or even hours to move less than a single rotation. And of course a rig like this can help with night photography, replacing star trail photos with images that pick up the faintest stars over time. I decided to design a time-lapse camera rig using an Arduino Uno as the brain, an LCD keypad for the user interface, and a stepper motor for precise control. I started with the stepper motors and ran experiments to understand how to control them with the Arduino. It took some careful experimentation to figure out exactly how many steps the motor had and to modify the Arduino libraries to allow precise control. This calibration was crucial to make sure the rig would support celestial photos accurately. I found this LCD panel that was recommended by a similar project. It was pretty easy to control using libraries that come with the Arduino development kit. I wrote code to allow the user to specify the number of hours, minutes, or seconds per rotation. This seemed like a better user interface than specifying RPMs. I ordered bearings, gears, clamps, and a motor shaft from an online supplier. I also bought a tripod ball head to allow the camera to be mounted at any angle. And I bought a USB battery pack to power the rig in the field. Now the trick was to put it all together. I designed a pretty complicated frame using SketchUp. It's 3 by 4 by 5 inches. This is the area where the electronics will be mounted. There are seats for the bearings here and here, and a ledge to attach the stepper motor. These holes are for attaching the motor controller board. I designed it to be used in 2 different orientations. When the bottom is attached to the tripod, the shaft will be vertical for panning time-lapse photography, but can also be mounted at a 30-degree angle for star photography. To align the rig's axis with the Earth's axis, you just sight the North Star through this peephole. Printing the frame took about 8 hours on the 3D printer. After it was done, I had to remove quite a lot of lattice structure that the printer software adds to support the upper layers of the design.
It turns out that 3D printing is as much art as science. Whether because of mistakes in the slicing software or design changes on my part, it took quite a few prints to get everything right. But in my final design, I got a clean print, and all the holes lined up well, making it easy to attach the electronics, motor, gears, bearings, and drive shaft to the frame. I needed to print one more adapter to connect the drive shaft to a 3/16 inch bolt that supports the tripod ball head. With that addition, the project was complete. Here you can see the rig in action, spinning once per 25 minutes. I've been really pleased with its performance. The panning is very smooth, whether it's spinning at 1 RPM or 1 revolution per day. I've taken some great star photographs with it, as well as cool time-lapse videos. Overall, it's been a really successful project.